Hello, everybody. Are incompatible on the wire. Full stop. There is no if or but or things like this. They are incompatible on the wire. They cannot talk to each other. They are like ships in the night. So, given the fact that we did not deploy IPv6 in a timely manner, because the idea at the beginning was, okay, 20 years ago or 18 years ago, IPv6 was standardized, and then they said, okay, we will just deploy it and take it off the ground, and then IPv4 will just die away. This didn't happen. Now we have a problem with IPv4. We don't have space anymore, as you may probably notice. And now we need transition and translation mechanisms. How to make these two worlds coexist with each other on the same network. So currently mobile operators are massively switching devices to IPv6 only. For example, T-Mobile USA. Last time I spoke with people there was 52 million devices on IPv6 only. 52 million Android phones in T-Mobile USA network is IPv6 only. They're using 464 XLAT and basically NAT64 on the other side as a translation mechanism. Verizon Wireless, all these operators are now moving to IPv6 only. So what were my questions? So I'm traveling a lot around the world talking to operators, and when I sense the generic problem, I start asking questions. And what I heard from people is, do content providers know how their content will be seen from such environments? If you are behind NAT64 and using it as a translation mechanism to reach IPv4 content, how will my content be seen to these environments? And then, does connectivity providers know what their users' experience on IPv6 only would be? Just because nobody is calling the help desk, that doesn't mean there are no problems. So, first, I set up 4 different NAT64 implementations in my lab and used the publicly reachable globally routable NAT64 prefix. So anyone that has IPv6 can remotely test any of 4 different implementations in the lab. Okay, let's get this part out of the way quickly. Acknowledgements, credits. Of course, I would like to thank Internet Society for dedicating my working time to do these crazy experiments in the lab. I would like to thank Go6 Institute in Slovenia for providing the lab, the hardware, the place, and everything. I would like to thank Sander Stefan. He is the main behind the programming of the tool that I will talk about at the end. And of course, Corinne Pritchard, she's Sander's girlfriend, for a lovely design from the tool's front end. And lots of hugs to Corinne. All right, so let me first explain how this public testbed works. First of all, it's aimed at everybody that would like to test DNS64, NAT64 environment. It's used by operators, it's used by application providers, it's used by hardware and software vendors, it's free. There is a link down there where you can read the instructions. So how does this actually work? You actually set the, as you see here, do we have a laser here? We don't, do we? Yeah, we do. Okay, cool. So here, you see this one. If you set your recursive DNS setting on your laptop or on your machine, whatever you have, and you have IPv6 connectivity, the DNS server at this address will just start actually synthesizing the quad A records if there are none. So it will give, if there is just a record and IPv4, you will receive back the A record and IPv4 address plus quad A record and the address that is composed of the NAT64 prefix that is routing your packet towards my lab, and then it's column, and then on the other side is IPv4 address in a hex format. It's quite complex, but have a look how NAT64 works. But what you have to do is you just set this as your DNS resolver and you will start forwarding packets to my lab. So currently we have A10 networks, Palo Alto and the firewall. YOL is a free open source version of NAT64, and we have a Cisco ASR1K. Cisco sent us the box to put it in the lab. Hopefully some other vendors will also send the box to the lab. So we would like to have as wide as possible the variation of the implementations, because, for example, Lorenzo Coliti from Google, he now works for Android. He sent me an email saying, Jan, thank you for running all these NAT64 implementations in your lab, because when we were deploying 464 XLAT on Android version 4.4, we just tested against your all implementations, and they were testing from Japan. And they said, we found some bugs in our code that did not show on the first two, but on the third one, the response was a little bit different, and then we found out that there is a bug, and then we fixed all the bugs. So we made the 464 XLAT implementation on Android work with all four of you. Yeah, thank you. So this is quite used. And this is the hardware. So as Sander subtitled this one, he calls this a systematic chaos. And it is a bit. This is my lab. These are, for example, Palo Alto boxes that are running. So this is a real hardware. It's not something virtual. This is a real hardware running the NAT64 implementations. Okay. We set up this, and we were happily providing the NAT64 testbed. And then when people start using it, then sometimes I go in the log files and see what's happening, and then I see all sort of weird things. So, first of all, I figured out that some people put a complete crap in quad A record. Some people put in column. That is not going very far. That is really not going to work. Believe me, I know what I'm saying. Some people put column 1. They really want to talk to themselves only. This is not going very far. Maybe if you have the web server installed on your laptop, then it will show the default page, but you're not going very far with this. This one, column, FFF column, and IPv4 address, also not going very far. FE80, of course, as you do, you put your link local address in your quad A record and publish it. Wise idea. Then you have 64 something. So somebody published the well-known NAT64 prefix address in quad A. Well done. And then this one, does anyone recognize this? Huh? Yeah, it's a documentation prefix. Somebody was okay, this proves that somebody was reading the documentation. And doing copy-paste, of course. This is also not going very far. So, if you have seen something like this, if you see the quad A with any of these things, please find the guy, talk to him, tell him that he's not the smartest guy on the world and that he needs to fix his things. But in between the 100% fixed ideal IPv6 world and the real world, you know, in theory, there is no difference between theory and practice, but in practice there is a big difference, right, between theory and practice. And we need to do something. So if you're interested, so Dan Wing, he used to work for Cisco, is doing his measurements. If you want to see all this stuff, go to this address. He's doing the monthly testing of what's happening in this arena. So what does this mean? If you have a NAT64 environment, if you have IPv6 only, the problem is that the DNS64 server, will not synthesize the usable quad A record, because the DNS server will get the quad A record and will say, okay, there is no problem, I will just forward the quad A record. And then you get this quad A record, and you have IPv6 only, and you are not going very far. And things breaks. So, for example, this one is nice. Let's break all the illusions. If you ask for host to www, first inside.com, you get the responses back. But if you ask without www, you get quad A record with column. Well done. So, what can we do about this stuff? If we are an operator, then we don't want to break user experience. If you are a mobile operator switching on IPv6, we don't want people to call our help desk. So what do? First of all, we need to figure out who these people are, contact them, warn them about the issue, and ask them to fix the problem. And always remember, if you are not part of the solution, you are part of the problem. And at the same time, I figured out that we could use the exclude rules in DNS64 software. So what do? IANA allocated 2000:3 as the global unicast address pool. And in my opinion, whatever ends up in quad A record and is outside this global unicast address pool allocated by IANA is just plain invalid, and it should not be there. So, for example, for bind 9, who is using bind in the room? Okay. So when you enable DNS64, and you probably will at some point in time, you need to put this inside. Exclude, that's the first part before 200/3, and that's basically the rest of IPv6 addresses, and also the documentation prefix. If you do this, what does this mean? This means that if the DNS64 server gets a quad A record with the value of anything outside 2000/3, then it will just ignore it and create the quad A record with the NAT64 prefix plus IPv4 address in hex. This is very simple. And that's how you protect your users from not having a really bad user experience. Okay. There is a little bit of moment of betrayal. Don't get me wrong. I'm a big proponent of DNSSEC because, of course, everybody needs to do DNSSEC and sign the zones, right? Who in this room signed the zone? Whooping 2. Okay, including me, 3 for the number. Okay. If you have the problem here is that quad A that is generated by DNS64, if the zone inside for your www.whatever.com, if my DNS64 server generates and creates the quad A for you, that is NAT64 prefix plus IPv4 address, then my DNS server does not have the key to sign that record, and so your DNS client would be able to verify it. So if you did sign your zone and you did not go to IPv6, please go to IPv6. Please implement IPv6, because then there are no problems. Then DNS64 will not be generating quad A records for you because you generated the quad A record there. But still, you need to put in the break DNSSEC yes configuration directive, because otherwise, see here is this is the query for the 4.go6.si at this server plus DNSSEC, and if there was no break DNSSEC yes in the configuration, then Nothing was returned. Oh, 10 minutes left. Okay. With break DNS yes, this is sort of like the Enigma machine, right? Here we got the response, and this is the NAT64 prefix, and this is the IPv4 address that is directed to. So, moment of betrayal, break DNS yes, otherwise things will stop working. Okay, here is the configuration for unbound. If you're running unbound, you put all this stuff in. Here you see that I was collecting all the anomalies, but then I just figured out, okay, let's exclude everything outside the 200/3 and be done with it. Okay, there is more reading how DNS64 and DNSSEC works together. This is a very nice RFC written by our friends. And if you want to understand how the whole Enigma machine works, go and read this RFC. Few examples, and I will not be finished in 10 minutes, I'm sorry. Okay, firewalls.com. Still waiting for the timeout. You see, here is NAT64 environment. Okay, indeed, very secure. Very secure. It's running on column, FFF, column something. It is very secure. For example, people from Spain, what does it say? Something broke on IPv6 and NAT64. I've been told they fixed it, so now apparently it's fixed. This one is from Slovenia, Shrani.si. This is sort of like online disk station where you can put your movies or whatever you want. And here it says that it is on IPv6, but it says you are not in Slovenia. You cannot store because geolocation didn't recognize me as from Slovenia. Well, I'm sitting in the middle of Slovenia in Go6 Lab, and you're telling me that I'm not from Slovenia. Well done. Okay. No quad A record. So there is no quad A record, but server is still confused. You get this. No apparent reason. We have no idea how this happened, but this is what you get on NAT64. Oh, German people. If you are selling things, people seeing this will not buy things from you because they will just not, because they don't see what you're offering to them. Really bad idea. Okay, the Gateway Pundit. Good server and bad content, you see? Not very attractive, is it? This one is, what's this? Household church. Problem is, they have quad A record, and the server itself responds to IPv6 pings, but then the web server is not running and is not attached to IPv6. There is no point in putting quad A record there if you're not running the web server on IPv6. Of course, it breaks. And also NAT64 will break. So that 52 million people on T-Mobile IPv6 phones, they will just not get your content because they will not. It will, for them, it will break because you have a valid quad A and it doesn't work. Yeah, then you have working quad A record and IPv4 only content. You see, this is something completely different. Here, I'm already showing bits and pieces of the tool that I will talk about later. Here, if you press this little triangle here, it shows you in great detail all the elements of the page, and then you see what went wrong in each environment. So, as you see, there are some issues in the real life on the internet on IPv6. So how to test for all these things? How to build a looking glass? So there are many things. There are many things to test. It's test on NAT64, test on IPv6 only. Did all resources load okay? Does it look good to the user? Do we see any path MTU issues? And we came to the idea to build a tool with Sander. It's called NAT64 check. And this is the first page. If you go to nat64check.go6lab.si, and you can all now test your machinery. It's online, it's free. Usually when I do this presentation, there is a spike in measurements done by the system, because then people go and start checking their content, how it's seen. So here inside, you enter your URL, whichever you want, HTTP, HTTPS, it doesn't matter, and then press the check button. Here, this is the first page, and here are the previous measurements. So your measurement will show up in the measurements page. For example, here you can use filters. You can say IPv6 good, and it will show you just good, the ones that the comparison was quite good, and things like this. You can do search, and you can do many different things. We also implemented the mouse over, because what the result shows is, so we compare all three. So we send out the request for content, and what we get back, we do the image, and we compare the images together from all three environments. NAT64, IPv4, and NAT64, IPv4, and IPv6 only. So we also did the mouse over. If you go with mouse over, you see that there is a difference. It shows you where the differences are. We don't fix brokenness here. So the DNS64 server that is used for this system does not have exclude statement. Here, if you have broken quad-A record, it will just break for you, and it will show you every possible brokenness that you have in your system. It will even do the path MTU, the discovery test. Currently, we have two instances. One is in Sanders' lab, one is in my lab. And how does this work? Some illumination theory. For servers, there is management server and the web interface, the one that you are able to access. And there is a server with IPv4 only, server with IPv6 only, server with NAT64. And in Go6 lab, we are running it on Proxmox virtualization cluster, and Sounder is running it on VMware cluster. We're using Phantom.js as a command line browser, where from these environments, we send the request for your URL, and whatever we get back, Phantom.js is able to render the image and send it back to the management server, and then the comparison is done. Images and words. Master machine, IPv4 only client talking to IPv4, IPv6 only client talking to IPv6, and this one is NAT64 that is talking to DNS64 and NAT64. Pretty simple. You need basically 4, 5, 6 machines. Okay, run the test and calculate the score. Please take the time, because when you press the button, the management server needs to send the query to all these environments, and then some images on some elements will not load, or will start to time out and things like this. Don't press the button many times, please. You will overload the system. Take the time, take a coffee, and wait a minute or half a minute for your result. It will show you like this. When the test is in progress, don't touch anything. Okay? So test your website. Wash, rinse, and repeat. You need to make sure that all the images load correctly and that everything loads correctly on all three different environments. Because if you're a content provider, you want to know how people is seeing your content from all these possible environments. Special thing is that if you're fixing a DNS misconfiguration, it might take some time before your fix propagates around the world and to our servers, so be patient with DNS. Come back tomorrow. For example, I saw this in the log. If you don't have a working domain with NAT64, things will just break. For example, where is it? That qq.com, the SOA record is not subset of something else. This will not work. The good thing is that I'm nearly at the end of my presentation, and I'm making chairs nervous down there. I would be, if I would have me on stage. But yeah, good thing is that it's on GitHub. The whole code is freely available. This is the link. Feel free to use it. We are always in look for help. If you are a Python coder and you would like to contribute to the code, more than welcome to come and talk to me or Sander. We would like to build a team around this project. We already have lots of suggestions how to improve it, but we are lacking the time. So we need all possible available hands for help. So if you're a content provider, test how people see your content from different environments. If you're a connectivity provider, test how IPv6 only and 464X let users sees the content. If both, all of the above. And you might be surprised. Here are also the links. And hopefully that the spirit carries on.